Protostar. A protostar is the earliest stage in the life of a star, and it begins inside a cold cloud of gas and dust floating in space. Over time, gravity pulls this material together, causing it to collapse inward. As more matter gathers, the center becomes hotter and denser, slowly building up pressure. At this point, the object is not yet a true star, because the core is still not hot enough for nuclear fusion to begin. Instead, it glows faintly from the heat generated by the collapse itself. Around it, you often find a spinning disk of leftover material, which can eventually form planets. This stage can last for hundreds of thousands of years, depending on how much mass is available. Eventually, if the core temperature rises high enough, hydrogen fusion starts, and the protostar officially becomes a real star. Main sequence star. This is the most stable and longest-lasting phase in a star's life. During this stage, the star is actively fusing hydrogen into helium in its core, releasing a steady flow of energy. That energy pushes outward while gravity pulls inward, creating a perfect balance that keeps the star stable. This balance allows the star to shine consistently for millions or even billions of years. The size of the star determines how long it stays in this phase. Smaller stars burn their fuel slowly and can last for an extremely long time, while larger stars burn through their fuel much faster. Our Sun is currently in this stage, which is why it provides a stable source of light and heat. Most stars you see in the night sky are in this phase, making it the most common stage of stellar life. Red giant. A star becomes a red giant when it starts to run out of hydrogen fuel in its core. As the core stops producing energy in the same way, gravity causes it to shrink slightly, which increases the temperature inside. This heat then pushes the outer layers of the star outward, causing it to expand massively. The star can grow to many times its original size, sometimes large enough to engulf nearby planets. Even though it becomes bigger, its surface cools down, giving it a reddish color. Inside, new fusion processes begin, such as the fusion of helium into heavier elements. This stage is much less stable than the main sequence and does not last as long. Eventually, the star will lose its outer layers, leaving behind a smaller, dense core. Supergiant star. Supergiant stars are among the largest and most powerful stars in the universe. They start out as very massive stars and evolve quickly due to the enormous amount of fuel they burn. As they age, they expand into enormous sizes, becoming hundreds of times larger than the Sun. Inside their cores, they go through multiple stages of fusion, creating heavier elements one after another. Each stage happens faster than the last, making their lives short but extremely intense. These stars are highly unstable and often lose material through strong stellar winds. In the final stage of their life, they can no longer support themselves against gravity, leading to a massive collapse. This collapse triggers a supernova explosion, one of the most energetic events in the universe, scattering elements across space and sometimes leaving behind a neutron star or a black hole. Red dwarf. Red dwarfs are the smallest and most common stars in the universe, yet they are also some of the longest living. They have relatively low mass, which means the pressure and temperature in their cores are lower compared to bigger stars. Because of this, they burn their hydrogen fuel very slowly and efficiently. Instead of having a layered structure like larger stars, their material is fully mixed, allowing them to use almost all of their fuel over time. This gives them lifespans that can last for trillions of years. They shine with a dim, reddish light, making them difficult to see without a telescope. Despite their calm nature, they can sometimes produce strong flares that affect nearby space. Many of the stars closest to our solar system are red dwarfs, blue giant. Blue giants are massive stars that shine with intense brightness and a distinct blue color. Their high temperature comes from the enormous pressure in their cores, which drives very fast nuclear fusion. This rapid energy production makes them incredibly luminous, often outshining many other stars around them. However, this power comes at a cost. They burn through their fuel very quickly, which means their lifespans are much shorter than smaller stars. While a star like the Sun can live for billions of years, a blue giant may only last for millions. Their strong radiation can push away surrounding gas and shape the space around them. These stars often evolve into even larger forms before ending their lives in powerful explosions. White dwarf. A white dwarf is the dense core left behind after a medium-sized star has finished its life cycle. When a star like the Sun becomes a red giant, it eventually sheds its outer layers into space, leaving only the hot core behind. This core is incredibly compact, with a mass similar to the Sun, but packed into a size comparable to Earth. It no longer produces energy through fusion, so it slowly cools over time. At first, it shines brightly due to leftover heat, but as billions of years pass, it gradually dims. The matter inside a white dwarf is packed so tightly that it behaves in unusual ways, resisting further collapse. It represents one of the final stages for stars that are not massive enough to explode as supernovae. Neutron star. A neutron star forms after the collapse of a very massive star at the end of its life. When such a star runs out of fuel, its core collapses under gravity with incredible force, compressing matter to an extreme level. Protons and electrons combine to form neutrons, creating an object that is unbelievably dense. Even though it may only be about 20 kilometers across, it can contain more mass than the Sun. The gravity on its surface is so strong that it would crush anything instantly. Many neutron stars spin rapidly, sometimes hundreds of times per second.